Show how you would carry out the following conversion, not more than 5 steps. So a student that comes to the exam, this type of conversion, he or she should have done at least 100 times, different reagents. So you see, this is a meta director. This is also a meta director. But the product obtained is auto para. Basically, it's a para position, one of these. So the simplest idea is, what you can do is, first you can convert this to a methyl group, right? Because if you have a methyl group like this, then you can add this NO2. Okay, so initially you will have this methyl group, then to get the para product, you have to get a methyl group. Then what you can do is you have to oxidize this. NO2 will be as it is, and this will be converted to a carboxylic group. So this one you can use CH3Cl and hydrous AlCl3, and for this one conc HNO3 conc H2SO4, and for this one you can use H plus KMNO4. So you have done 1, 2, 3 steps. That's done, right? Otherwise, you can use instead of Friedel-Crafts alkylation, you can go through a Friedel-Crafts acylation as well, right? You get the acylation, then you convert to CH2CH3. For an example, COCH3 you add here. Then you do the CH2CH3 reduction, and then you add NO2, then you do the oxidation. It's your wish, but this is just 3 steps. This is done, right? So 2 compounds A and B are required to be prepared in the laboratory. So these 2 are the compounds that we have to prepare in the laboratory. Show how you would prepare A and B, not more than 5 steps again, using X and Y as required. So you can use X and Y as many times, but you cannot exceed 5 steps. So let's think about X and A. So 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbons. So the simplest way is just to do some, add some reagents to convert this to this, because the carbon number is same. It's very same, right? So what can you do here? There is a bromine here. So in the same way, we usually think. So we can think this might have been come from like CH3, CH2, maybe like CH alkene, maybe. This might be this. Or maybe this can be like CH3, CH2, and CH alcohol. Here there is OH, then you convert that using PBr3, or just to convert this OH to Br, right? So these 2 are possible, right? But how can I get this one? This one might be coming from the ketone, right? So CH3, CH2, CO ketone. So this one can be automatically directly taken from this one, right? You can add the hydration, right? HgSO4, H2SO4, water. When you add this one, you will get this. And this to this, you can do the reduction using sodium borohydride. And this to this to directly to this, you can add PBr3. So 1, 2, 3 steps. Nice. Then how can you come to this secondary alkene thing? You can add quinoline medium, right? Palladium barium sulfide in quinoline medium. You can reduce this triple bond to double bond. And then to get this one, you can add HBr. So nicely, you can take this one, 1, 2 step. Here, 1, 2, 3 step. As far as you like, you can use it, okay? Because both are less than 5 steps. Then B here. So what do you think? What can you do with B? So here I see a carbonyl compound, right? So what you can do here, you can convert this to this one. And here 1, 2, 3, 4 carbons. Here 1, 2, 3, 4 carbons. 5 carbons, 6 carbons. So it's like the combination of these 2. But when I convert this to this one, and then I add this one to this as a Grignard reagent, there is a branching here that is going to happen away from CH3. But there is no branching here in this structure, right? So the easiest way to do here is add these two directly to this acidic hydrogen. So what you can do here is you convert this CH3 to CH3, CH2, MgBr. And then you add this to this acidic hydrogen so that you will get now CH3, CH2, which are these, and carbon triple bond, because Grignard is going to destroy because of this, but this CH3, CH2 is going to combine here. Oh, sorry. CH2, CH3 here. And this one, you can just add the GSO4, H2SO4 water to get this one directly, right? So the first step is converting this to a Grignard, then you add these two. Then finally you do the reduction. Okay. Either you can keep this alkyl halide as it is, CH3, CH2Br, and you convert this acidic hydrogen to adding NaNH2 to sodium. Then you just add these two without converting this to a Grignard reagent. Okay. You can do as you want. So this is also done. Show how you would prepare the compound C, this one, using A and B given above, not more than 5 steps. So A and B is this. So you can imagine 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 1, 2, 3, 4. So all these carbons are here. When I see here this structure and this structure, this part I see is here, and this part I see here. And this is structure, this part I see here, and this part I see here. So it's typically combined through these two. It's like combination between these two. So how can I combine these two? Using a double bond. The easiest way is you make this a Grignard reagent like MgBr, and then you attack this one as a Grignard attacks, and you can have this OH and this single bond. So the step before this will be like one of the carbons where the Grignard, this CH2 CHOH, so this would be OH, and this will be hydrogen here. And when you do the dehydration, so this double bond will be formed. This double bond will be formed. So very simple, right? These are very common questions. And the last part is using your knowledge of the mechanism of the reaction. So we have discussed this mechanism before also. Okay. Because I told you in the ester hydrolysis first, so when you have OH minus, what is happening? This OH minus is going to attack this carbonyl carbon, and this is going to form the negatively charged species. So it will be CH3 O minus, or CH3, and there is OH here attacked. But I have told you the halogens and the ester groups, these ether parts, they are good leaving groups. So this is going to form like this, and this bond is broken like this. So at this step, but don't forget there is sodium as well. So put here sodium plus as well. Then here it will form CH3 double bond OH, and this OCH3 is removed, right? But at the same time, don't forget this carboxylic acid will not remain as this is, because NaOH is still in the medium and carboxylic acid react with NaOH. So as a final step, you can write this as with NaOH. So what is going to happen? Here there will be CH3 COO Na plus minus is formed, right? Because there is this hydrogen replaced, and water is formed additionally with OH minus H. Okay. The only point that can be missed here is this one, the carboxylic acid converting to the salt. Okay, that part might be a little bit of tricky in nature. But don't forget, we have already discussed this many times.